Saxon Algebra 2, Lesson 121. Students, Jayla and Lydia, this is our last week of new lessons. This is it. And I don't have I'm still fine-tuning my plan, but chances are we will not have, maybe we will, but I'm pretty sure that it's going to be 4. So, we're definitely in the home stretch. We are coming down the last stretch, you guys. This is it. The final will work just like the midterm. I may mix it up a little in terms of what lessons I'm representing, but don't worry about that. I'll go through the same process though, where we'll have one lesson where I'll just go through and map out for you how I'll build the test, what lessons I'll consider, and then I'll drop the tests off. It'll be a week from Wednesday is the day we'll actually have the test. I don't have the date in front of me, but it's early May. So, wow, that's pretty cool. Buckle your seatbelts. We're almost done. This lesson is called, fuzzies, rational inequalities. Okay, we're building on what we have been doing. Sorry, my book feels low. There we go. Okay, we know how to graph something like this, right? X squared minus x minus 6. Let's say it's greater than 0, right? We know how to do that. We know that first we break this down and make it, what would it be? X minus 3, x plus 2 is greater than 0. This tells us we want our answer to be a positive number. We want to have a positive product, right, when we multiply these two things together. And so then that tells us we need to set up these two binomials either to both be positive or to both be negative, blah, 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 blah from there, right? You know how to do it. I don't have to keep going. But this is our starting place. What we're going to do now is go one step backwards, one step further backwards, and start from a slightly weirder starting point, okay? Instead of just being here with a nice quadrilateral to begin with, quadratic, I believe is the word I was searching for. Quadratic equation, we're going to back it up another to this point, okay? So, like with so many algebraic processes, we started early and now we're adding steps in before where we used to start. Okay, so this is the way our problem is going to look. And there are only 2 of these, and John's not really going to make it much harder. Notice that we're using our original presentation. We're not using that set builder notation that we've done. Okay, this is what's weird. What the heck do we have going on here? This is very strange. We have a denominator with a variable in it, right? Okay, so let's figure out what we would do with this. The first thing I'm going to write down is that x cannot equal 4. Because if x were equal to 4, this denominator would blow up just like the kingdom. There would be a big mess on our hands. It's not going to work. We'd be hiding the bodies. No, we cannot let x equal 4. We're going to set this information to the side, and then when we go to graph, we're going to make sure that that is true. Okay, so that's why I wrote it here, so that when I check this to make sure I'm graphing the right domain, I'll see this and be like, oh, right. So those are both pieces of information for later. Okay, now, if this were an equal sign, here's what we could do. We could multiply both sides by the denominator, right? And then this would cancel, and we would be fine. We would go on from there. But this is a problem with an inequality, and here's why. We're multiplying both sides by x minus 4, but what if x minus 4 was a negative number? If x minus 4 ended up being a negative number, then we would have to flip the equal sign, or the inequality. Shoot, we have no way of knowing if we need to flip this or not, because we have no way of knowing if this quantity, x minus 4, is going to end up being positive or negative. We won't know until we solve it, but we can't until we know whether or not to flip this. So, what we're going to do is employ I'm not going to say a trick, I'm going to say an extremely clever strategy. Instead of multiplying it by just x minus 4, we're going to multiply it by x minus 4 squared. And instead of just writing the square, I'm going to write it out. Later we'll take that shortcut. If I multiply it by x minus 4 quantity squared, I know that will be positive. X minus 4 quantity squared must be positive, which we know because even if you have a negative number, if you square it, it'll always be positive, right? That square, we know that the result has to be positive. So if we multiply by quantity x minus 4 squared, we don't have to worry about flipping the sign. Isn't that so clever? I love that somebody thought of that workaround so we wouldn't have to deal with this drama. All right, so using that's because that's written there. I would write it just like this. And in the next problem I will. So now we solve from here. Both in the numerator, right? This is in the denominator, so we can cancel one of those. Okay, that looks good. This one, let me go back and finish simplifying this side. Then we'll have to distribute this minus 1 across the remaining x minus 4. So on this side of the inequality, we're going to have minus x plus 4. Okay? When I was looking at this in the book, that got really confusing to me until I realized, oh, we had to distribute the minus 1, that's why the sign's flipped. That's weird. Okay, now on this side, square that binomial, multiply it by 1. Oh, excuse me, that's nothing. So, let's just write that. You can probably do these pretty well in your head. If you feel like you can do them in your head, feel free to do that. I'm going to multiply it out, and then I'm going to remind you how to check your answer. X squared minus 4x plus 16. So this becomes, whoops, I forgot to put this way again. X squared minus 8x plus 16. And notice you can double check because these two multiply to this and add to this. So that's another way to do it, right? So if you can do these in your head, feel free. So that's what we have on this side now. X squared minus 8x plus 16, right? Okay, good. Now we can just clean up the algebra by swimming these guys over here. Plus x minus 4 minus 4. Goodbye, goodbye. Notice we're subtracting, but we're not dividing by anything. Up here we multiplied by -1, but it was all on one side. Fine. We weren't moving anything across the inequality. That would have triggered a flip. But this does not trigger a flip because we're just cleaning house. This doesn't trigger a flip because it's subtraction, not multiplication or division by a negative number. Oh, what a relief, right? So over here we get x squared minus 7x plus 12. And John, buddy and pal that he is going to make these factorable by inspection. This will be x minus 4, x minus 3. No quadratic beastiness at this stage of the game. John is kind. Okay. Oh wait, I'm jumping ahead. We still have to do this. We want these two to be less than 0, so that means we want a negative number. So that means our two choices, I'll just use this line as part of it. We want either a plus negative or a negative plus, right? So now I'm taking these two binomials and setting them up this way. X minus 4 is greater than, and because there's an equal sign there, we'll put an equal sign here. Is greater than or equal to 0, and then x minus 3 is less than or equal to 0. That's one option, or we can do it the other way around. X minus 4 is less than or equal to 0, x minus 3 is greater than. Okay? This is a less than inequality, so I remember back to how we learned them. This is the one where one works and the other one is nonsense. Okay, good. Let's graph both of them. Oh, we have to do the algebra on these. I'm going to add 4 to both sides, so this is x is greater than or equal to 4, and x is less than or equal to 3. That sounds like nonsense to me. How can a number be greater than 4 and less than 3 at the same time? Doesn't work. And then this one, add the 4, x is less than or equal to 4, and x is greater than or equal to 3. Okay, that seems like something we can graph, right? This one is the empty set, the null set, no solution. Okay, that's what's going on over here. This one is graphable. I'm going to graph it right here. So we want the values of x between 3 and 4. We want the reals. Aha, this is important, right? Because if I were graphing this, I'd put a solid dot at 3 and a solid dot at 4, and I cannot be equal to 4. So this is going to have to be a circle. Even though our solution says that the 4 can be part of the solution, we said up here that 4 cannot be part of the solution. 3 is cool. So that is our final answer. Yay! Makes sense? This is kind of a fun little one more thing to think about. I mean, I think it's fun. You might just be annoyed. But strategic weapon came way up here in the beginning when we multiplied by the square so that we knew we had a positive number. All right, let's do it one more time. With a new problem. Example 121.2. Okay, this time I'm going to put lots of space around my problem so that I don't get squished. Graph m minus 2 over m plus 2. This problem has been on many a final exam I've written. Just saying. Domain equals reals. And we know that m cannot be equal to minus 2, right? Because that would be, we always look just at the denominator, and we just, I mean, you can say, you can do it like this. M plus 2 cannot be 0, right? And then we just subtract 2 from both sides, and we say m cannot be minus 2. You can always solve it by setting the denominator equal to 0, as we did here. But if you can just look at this and go, oh, minus 2 would be a problem, that's fine as well. Think of it as a calculation, but it's a good idea to know that this is the process. We take the denominator and say that cannot be equal to 0. Okay, so we'll look at this. That's not the answer, but we'll look at this just like last time to make sure that we don't inadvertently include that as our solution. And again, remember the reason we're doing this is because we cannot blow up the universe, which is what would happen if we let this turn into 0. All right, so we need to eliminate the denominator. We know that this would solve that problem by m plus 2, but because we don't know if this number is positive or negative, we don't know whether or not to flip that, and we've got a problem. So we multiply by the square of the denominator. And again, if you want to, you can just write this as a square, but I like to write it out so that when you cancel, you can see what you're doing. All right, so now we're multiplying by the square of the denominator. I'm going to write that because, you know, that's a helpful hint. Multiply by the square of the denominator. Puffy cloud of helpful knowledge. Okay, so that's what we've done, right? There are the squares. Now, on this side, the left side, one of them cancel, and we're left with m plus 2 times m minus 2. Because we're left with this and this, right? Okay, now over here, we're left with, I'm going to go down, let me write it again, just so I have more space. My puffy cloud of knowledge is getting in my way. All right, so I just copied that, that's the same, is less than 2 times m plus 2 times m plus 2. Okay, because that's just the square, right? This started out just being a 2. All right, so the minus is only on the left side. On the right side, we have 2 pluses. All right, so I'm going to try doing these in my head. If you don't like that, if that seems too much, go ahead and write them out. But I'm going to figure this one is m squared. Oh, this is a difference of 2 squares. So the middle term collapses. It's m squared minus 4. Right? That makes sense because this would be, if we multiply it out, it would be plus 2m and minus 2m. Okay, so this looks good to me. And then this is going to be 2 times, this would be m squared plus 4m plus 4. Right? And then I'm going to distribute this across. So we have m squared minus 4 is less than or equal to 2m squared plus 8m, hi cat, plus 8. Oh, here's Luna. He's walking on the table. Hello, kitten. You know you're not supposed to be on the table, but I'm going to let it go. I'm going to pretend I don't see you. Okay, so we have now cleaned up these multiplications. Now we're ready to push everything. This time let's push to the right side, and then we'll flip it because I don't like it on the right side. So we're going to add 4 to both sides. And then we're going to subtract m squared. That's good because I wasn't liking that 2m squared. We're subtracting, but we're not multiplying by any negative numbers. All right, cancel, cancel. Now I'm going to write my answer over on this side. That'll be confusing. M squared plus 8m plus 12. And now the open side of this is facing that, so it'll go like this, right? I'm flipping it only because of the way I'm recopying it. And we've got 0 left over there. All right, so that's not technically flipping it. I'm just rewriting it and making sure that the inequality sign is facing the right way because I changed the size. All right, let's see if John is being kind. M plus 6, M plus 2. Looks like it's going to get the job done. Multiplies to 12, adds to 8. Yay! Okay, we want this is a greater than inequality, so we want to end up with a positive number. So our options are either both are positive or both are negative. I'm squishing here a little bit because I want to get this all on one page. I hate flipping back and forth between the pages. So this is a little crowded, bear with me. So we want m plus 6 to be greater than or equal to 0. Remember, if it's equal then, we use it down here. If it's only greater than, we use that down here. M plus 6, m plus 2 also has to be greater than or equal to 0. Or they're both negative. M plus 6 is less than or equal to 0. M plus 2 is less than or equal to 0. Yay! Okay, now we're ready to clean up the algebra. And is greater than or equal to minus 6. And is greater than or equal to minus 2. This is again. Okay, this is a greater than inequality, so one is going to give us one side and the other is going to give us the other side. So we'll make two little. M is greater than minus 6 and minus 2, so the combined, here, it will be like this. Dot, go that way, dot, go that way. So this is what goes on our final solution. We go to minus 2, make a solid dot, and go that way. And then here we have minus 6, minus 2. This one goes that way, this one goes that way. Here's the combined. So then we do minus 6 down here. Now I'm graphing this as if it was the reals. Let's double check. Oh yeah, reals. Oh, m minus 2. So I have to fix this. I have to make this an open circle, not a dot, right? Yay, that's the right answer. So that's an open circle, which is confusing. But, because I've made it so clearly an open circle, and I might even write, if I were up taking the test, I would write something like that so that my grader knew for sure, because this kind of looks like both, doesn't it? I would be really clear which one I meant, because I can't erase. I could draw it over if I wanted, but that helps me as a grader know exactly what I meant. Okay, that's the end of lesson 121.